All right, so this is an introduction to BGP routing protocol. And those of you who have taken Cisco classes before, what I'm trying to do with these labs for this data center class in the cloud is, again, as I mentioned before, in a data center, you'll be working with racks, and on those racks are not only servers and virtualized software, and of course, cloud platforms, but also routers and switches. And so the goal of this class is try to broaden your understanding of routing and switching, and go through some labs that you might not have completed while you were enrolled in the Cisco Academy, which is primarily infrastructure when it comes to interior routing. So when we get into BGP, when it comes to routing, it's important to understand there's two types of routing protocols. There's an interior routing protocols, which is designed for routing within your own network infrastructure, within your own inner network. So you can have a collection of networks under your control that's maintained in several buildings. And you could take a college campus, for example, in which there's several buildings, and within that entire college campus, right, you have several, if not more, routers. And what they're doing is they're sharing routing information with each other using an interior routing protocol, such as EIGRP or OSPF, right? Protocols that you went through when you went through the Cisco Academy. But then we get into what's called exterior routing protocols, and BGP is an exterior routing protocol. And what I mean by that is sometimes the routing protocol of the internet. So when you're dealing with BGP, you're looking at routing at a higher level. For example, routing between internet service providers, public addresses within autonomous systems. So you can have a collection of major autonomous systems with public IPs, and BGP can share routing information among their BGP peers. So I actually cut and pasted a definition of BGP from the internet. And again, it refers to a gateway protocol that enables the internet. Now, we're talking about the internet, right? So when we speak of internet, we're speaking public IP addresses, not the private IP addresses that are interior to your network. Okay, so it enables the internet to exchange routing information between autonomous systems. And as these autonomous systems interact with each other, they need a way to communicate. And this is accomplished through peering, and BGP makes this possible. So what we're going to do is go over this topology real quick, and then we're going to configure this lab. So as you can see, in this example, there's three BGP routers. And let's start with the one at the left, right? Now I'm using public IP addresses, and the router on the left is within the autonomous system number 20, okay, with public IP addresses. And then in the center, you have a center router using the autonomous system 35. And on the right, you have a BGP router within autonomous system number 50. And as you could see, all public IP addresses. So we're going to use, public IPs throughout the topology. And so, as you can see from this topology, the center router is kind of the intermediary in exchanging routing informations between autonomous system number 20 and autonomous system number 50, because you got 35 right in the middle exchanging routing information between both of them. And so what we're going to do is we're going to configure the lab. We're going to start with configuring our PCs, okay? And then we'll configure the left router, the center router, the router on the right. We'll do some BGP show commands. We'll look at the routing table, and we'll make sure, like for example, that PC0 can ping. It should be able to ping PC1 because it's on the same subnet, right? But the PC0 can ping PC4 and PC3, okay? Or one or the other, because again, they're both on the same subnet. So let's go ahead and get started, okay? So we'll configure PC0, And everything's going to be statically assigned addresses. We're not going to use DHCP. We're going to click on PC0, and we're going to select the desktop tab and click on the IP configuration window. And we're going to key in the address of 191.168.20.2 because the gateway is going to have the .1 address, right? And PC1 will have a .3 address. And then the subnet mask is a /24 or 255.255.255.0. So make sure it reads as it's shown right here on the screen. And then key in your default gateway address. It hasn't been configured yet, but once we do, that will be the address of the default gateway, 20.1. Okay? Hit the tab key. You can close the IP configuration window, and you can minimize the PC0 window, and then you can click on PC1. We'll do the same thing, only we'll give it a .3 address, so desktop IP config, and then we'll key in 191.168.20.3. Okay, so if you accidentally type in 169, what you're doing, you're placing the PC1 in an entirely different subnet, right? Because of the subnet mask, 255.255.255.0. Again, that says that the first 3 octets represent the network portion of the address, right? And so we'll key in our gateway at 191.168. My fingers are kind of getting fat because I'm using a laptop and I'm always hitting the wrong keys and I'm opening up other windows. So here we go. So we'll do a gateway address of 191.168.20.1. And we'll hit the tab key, close your IP configuration window. Okay. Now from here, we can configure the left router. There's nothing special we're going to do on the switch. We'll click on the left router, click on the CLI tab, and as you can see, I've got the instructions written down here in the notes section on the topology. So we'll press enter to get started, and we'll do a couple of things. We'll type enable, enter, config T, enter, and we'll give it a host name, and we'll call it left. We'll make it in all caps. And then we'll start configuring the IP address on the gigabit 00 interface. Now, if you want to see the actual interfaces, you click the options menu, go to preferences, and put the check mark on always show port labels in the logical workspace. It's going to make it look cluttered, right? But you could see like gigabit 001, gigabit 000. So it's kind of cluttered, but again, you can do that if you wish. I'm going to turn it off, but you could see this topology for now. And I'll go back to preferences and uncheck it. Okay, and then I'll click on my left router again. And then we'll configure the gigabit interface. We'll type int g0/0/0/0 IP address. You can abbreviate it 191.168.20.1 255.255.255.0 and do a no shutdown command. Okay, and right now we're just configuring the interface. Now we're going to configure the interface right here, the interface that's connected to the center router. And we're using the gigabit interface G001 on left that will be connected to the center router. Now notice it'll have an IP address of 1.1.1.2 with a subnet mask of /30, okay, which is 255.255.255.252. So we go int G0/0/1, enter, IP address, I'll abbreviate this time, 1.1.1.2, 255.255.255. I put a .0 there. It should be a 252. Okay, good thing I caught it. So let's go here. I'll just change this to a 252 in my notes and click off it. And that fixes it, okay? Sorry about that. So you can see in the notes it's a 252. And then we'll go ahead and we will click back on the left router and we'll key in the .252. Okay, and then we'll do a no shut. Okay, so a couple things to keep in mind, right? You notice the dotted line. I'm not using a serial connection, right, which simulates a wide area network connection, and you have modem and a timing signal. I'm using a crossover cable, right? So what you have to remember when you're using an Ethernet connection, right, a wired cable, that the maximum distance on that cable is 100 meters. So the distance between the left and the center router has to be within 100 meters, which is still kind of far, right? It's about 3 football fields. So, and that could be plenty in a lot of cases, especially on a college campus. Okay, but I had to use a crossover cable because when you connect a router to router together, when you connect two devices together, like a switch to a switch or a router to router, you have to use a crossover cable, not a straight through copper cable. Something that you would have learned in the academy, right? In the Cisco Academy. So keep that in mind. I'm using crossover cables with the dotted lines in the topology. Okay, now when you're connecting a switch to a router, it's a straight through cable, right? So you don't have the dotted line, or a PC to a switch, it's a straight through cable. Okay, so our next step, now that we've got the interface configured, is to configure BGP routing. And again, it's different than EIGRP, in which the autonomous system numbers have to match, right? In EIGRP. In BGP, when you connect to another router, your autonomous system numbers that don't have to match. You just have to identify your autonomous system number. And so we have 3 separate ones. We have AS20, AS35, and AS350 on the right. Okay, so we key in router BGP 20, which represents the autonomous system number. Okay, you notice how your prompt changes to config router. Next thing you do is you give the router a router ID. Now, you have to be careful on the router ID, okay, because when you're connected to other routers, okay, in the same, like AS, then the router ID that's highest will be the preferred route under BGP. So for example, if you got like a full mesh topology with routers and they're running BGP within the same autonomous system number, and you have 2 ways to get to your destination. You can go the left way, you can go the right way, right? And then it goes to a router and then it goes to its destination. But you can go either left or right, but you prefer the left, maybe because the router has a higher processor, higher memory, it's a newer router, etc. So if you prefer the left, you would have to give the left router a router ID that's higher than the router on the right. So just pay attention to that. Now this is between routers in the same AS, right? And if they have identical routes to the same address, destination address, which one do you choose? Well, under BGP, you're going to choose the one with the highest router ID. So just be careful about that. So in this topology, we'll give the BGP router ID, router-ID, we'll give it an address of 3.3.3. Okay, now normally in the real world, you wouldn't want to use a public IP. What you would want to do is assign a loopback address on the left router, and you would want to assign it a higher router ID than other routers. So that's how you would do it in the real world. I would use a private IP, and for example, I would just put a network address of 192.168.100, .1 on the loopback, and that would be my router ID on the left. And on the router on the right, I don't want it to be the preferred route. I'd assign a loopback address of 192.168.99 because it's lower, .1, and use that as the router ID. So the left would become the preferred route. Okay, so from here, we're going to hit enter. Now we're going to establish who our neighbor is, right? So our neighbor is going to be the center router because we're directly connected to it. Okay? The right is not our neighbor. Your neighbor is only the router you're directly connected to. Okay? So you consider the person living right next to you as your neighbor, but if they're two houses down, then you would say, well, they're not my directly connected neighbor. Okay? So the center router has an address of 1.1.1.1. That will be our neighbor. And the center router is using an autonomous system of 35. Now, even though we haven't configured it yet, we're going to go ahead and key that in. We're going to type in the command neighbor 1.1.1.1 remote AS, and we're going to key in 35 and hit enter. Okay. Now, just like EIGRP, you have to advertise all the networks that are directly connected to you, right? So we have two directly connect networks, 1.1.1.0, 191.168.20.0. We have to advertise them. And it's done in a slightly different way. You still put a network statement in there, and you identify your network, 191.168.20.0. Only you got to type the word mask under BGP, and you type 255.255.255.0 because you're using a /24. And then you key in your second network, 1.1.1.0, mask, 255.255.255.252. And go ahead and hit enter. Okay? Well, that completes the configuration on the left. So you key in the command. Let's just type end, hit enter twice, and we do a copy run start to save it. And just hit enter to accept the default file name. So that completes the configuration on the left router. Next task is to configure we'll do the right first, and then we'll do the center, and you'll see how how everything is bridged together. So we'll configure the right router, and I'm sorry, I clicked on the switch. We'll click on the right router, click the CLI tab. Okay, and see, I'll put this right here where you can actually still see the instructions. Okay, that'll work. You can still see it. Okay, so we'll press enter, and we'll do an enable. I'll abbreviate this time, config T. You can watch what I'm doing. And then from here, we will key in the command host name, and we will call this one right. Okay, and then we'll configure the gigabit 00 interface. So again, if you want to see your port numbers, right, the router on the right connected to the center router. So I'll briefly show the port labels. The right router is connected to the center router on gigabit interface 000, while internally it's connected to the switch on gigabit 0001. All right, so I will turn that back off, and just to make sure we're doing it correctly, right? And then we'll click on the right router again, and we'll type interface G0/0/0/0. We'll give it an IP address of 2.2.2.2, 255.255.255.252, and we'll do a no shut. Now, again, as a reminder, in this case, descriptions are good, right? So if you want to add a description to it, you can say connection to center router. And again, you can have spaces between words in your description. You can't do it on host names, but you can get around that using dashes and underscores in the host name. Okay. And then next we'll configure the internal interface, gigabit G0/0/0/1, and we'll type in the command IP address 193.168.20.1, 255.255.255.0, and we'll hit enter. We'll do a no shutdown command. And if you want, you give it a description. Interior network for AS50. Okay. And after you configure the interfaces, the next step to do is configure BGP routing. Okay, so again, you type the command router BGP and you identify your autonomous system, right? So you type 50. Okay, you're going to assign a router ID, BGP router ID 4.4.4.4, and we're going to identify our neighbor. Now, our neighbor is the center router right here. If you follow my mouse, that will have an address of 2.2.2.1. So that's our neighbor. So we'll key in the command neighbor, and we'll key in 2.2.2.1 remote AS 35, right? That's the center router's autonomous system number. And next we will key in our network statements. So again, network's directly connected to us. Network 193.168.20.0, mask 255.255.255.0, and then network 2.2.2.0, mask 255.255.255.252. Okay. Now that completes the configuration. You can type in end and you can do a copy run start to save it. There I go again. Twice. Okay, so I can minimize this window here. Okay, and what we need to do is configure the addresses on the PCs, right? So we'll start with PC. Actually, we do PC3. And click on it, click on Desktop tab, IP configuration window, and the address will be 193.168.20.2, because remember the gateway has a .1 address. The mask will be 255.255.255.0. Notice I didn't have to add the extra 255 because 191.168, right, on the left side is actually a Class B address. So the default subnet mask is 255.255.0.0. But once it becomes 193.168 on the right side, that makes it a Class C address, and then the subnet mask is 255.255.255.0. And then we'll key in our gateway address, 193.168.20.1. Tab, close the IP configuration window, and minimize PC3 window, and then we'll configure PC4. And then we'll click the Desktop tab, IP configuration window, and we'll key in 193.168.20.3. Okay. Tab over to the gateway address, 190. Let's try that again. 193. This is the gateway address, 168.20.1. Again, so that's how it should look like, right? And then you can close the IP configuration window and minimize the PC4 window, right? And you can verify all these addresses. You point your mouse over PC0. It should be 20.2, 191.168.20.2. The gateway should be 191.168.20.1. You point your mouse over PC1. You can verify the address should be 20.3. Likewise, PC3, it's 193.168.20.2, and the gateway is 20.1. And then you hover your mouse over PC4. It has a 20.3 with a gateway of 20.1. Okay. Last step is to configure the router in the center. So we'll click on the center router. Okay, and I can move this over a little bit. Expand the window a little bit. Click on the CLI tab, and we'll press return to get started. And we will type enable, and then we will type config T. And for the center router, following our instructions, we'll configure the interface gigabit 0001, hit enter. Now again, that's the connection to the left router, and it's going to have an address of 1.1.1.1 assigned to this interface here. So we type IP address 1.1.1.1, 255, 255, 255.252, and we'll do a no shut. You can give it a description, and we'll call it connection to left router AS20. Okay, and then we'll configure the other interface, which is connected to the right router. So we'll go INT G000, right? And then we'll key in the IP address of 2.2.2.1, 255, 255, 255.252. And then we'll do a no shutdown command. And we'll give it a description. We'll call it connection to right router and AS50. Okay. Now we'll set up our BGP routing. Again, router, BGP, we identify our autonomous system number in the center, which is 35. Okay. Let's do a router ID. We'll type BGP router-ID. We'll call it 5.5, 5.5.5.5. Hit enter. We'll establish our neighbors. Now the center has two neighbors, right? Connection to the left, connection to the right. So we'll do the connection to the left first. We'll type neighbor. The neighbor's IP address is 1.1.1.2, which is the interface on the left router. Okay, hit the space bar and then type remote-AS20, which is the autonomous system number for the router on the left. Okay, and hit enter. And notice that the adjacency pops up, right? Just like you would see in EIGRP. And then we'll type neighbor 2.2.2.2, which is the IP address right here. 2.2.2.2 for the interface with the router on the right. Hit the space bar, type remote-AS, and type 50, because that's the autonomous system number for the router on the right. Okay? And that neighbor adjacency pops up. Last thing to do is advertise our networks, right? The ones that are directly connected to us. So we type network 1.1.1.0, mask 255.255.255.252, and then we'll type network 2.2.2.0, mask 255.255.255.252. Okay, so now that that's up and running, we've done our center router configuration. You could type end, and let's do a copy, run, start, and save the config. Okay, so that completes the config, right? But before we do ping and we test connectivity, let's go over our show commands in BGP, right? So for the center router, oh, I forgot to do the host name. Let's do that real quick. Config T, type host name, call it center. Then you can type exit, and now you can do a copy, run, start again. Okay? So the first thing we do on the center router, okay, is look at our show commands. We want to see who our BGP neighbors are. And it should be the router on the left, AS20, and the router on the right, AS50. So we type the command show IP BGP neighbor. Oh, I spelled it wrong. Show IP BGP neighbor. Okay? And notice I didn't completely spell out neighbor, but it still worked anyway. So we can see who our neighbors are, right? So first BGP neighbor is 1.1.1.1.2, which is the left router. The remote autonomous system is 20. Okay, and let me bring that up again. And as we can see, it identifies the router ID for the left router, which we assigned as 3.3.3.3 right here in the instructions. Okay, and then we'll hit enter to scroll down. Let's look at our second neighbor. And this is the router on the right, right? BGP neighbors 2.2.2.2, which is the IP address for the router on the right. Notice it's autonomous system number 50. So that's identified. And you also get the router ID for the router on the right, which was 4.4.4.4. So if you look at the instructions here, right, you can see we assigned the router ID of 4.4.4.4 for the router on the right. And so you can hit Q from here. Okay, you can do a summary BGP command. So you could type show IP BGP summary. Okay, and this output isn't quite as much, and it shows your information about yourself, right? So the router identifier for the center router is 5.5.5.5. Our local autonomous system number is 35, right? We got 5 network entries, okay, and we've got our neighbors identified in a summary format, okay? So last thing you want to do before you want to try to ping from PC to PC is go on each router and make sure, for example, the center router can see the internal networks uh, advertised to it from the left and the right. So we're going to type the command show IP route. I abbreviate show. Okay, so we got 193 being advertised to us. The connection is down here, so there's something we need to check between the left router and its connection to the switch internally. So that's why we troubleshoot first, right? Because this network is not showing up in the center router's routing table. So we'll need to troubleshoot it. But the network on the right, 193.168.20.0, is showing up in our routing table, right? And we know it's a BGP route because of the code B. Okay, so what we have to do is troubleshoot and figure out what is wrong. And the first thing to do is probably go to the left router and look at let's verify the interface. So I'm going to go back to options, preferences, show port labels. Okay, and the interface should be G000. Okay, I'll take that check mark off. The IP address on that interface should be 191.168.20.1 with a mask of 24. So I need to look at that. So we go to the router on the left. Okay, let's hit enter. And let's go enable. And let's type the command show IP interface brief. Let's get a brief summary of our interfaces. Okay, so the gigabit interface, for some reason, the status is down, right? Looks like the IP address 191.168.20.1 is valid, okay? And so from here, I want to do the show run command, or we can do show interface G0000 and hit enter. Okay, we got the line protocol down for some reason on this interface, right? It's disabled. And what I'll do in this case is you have to check the connection. So the cable connection looks good. So let's do a show run. Let's look at the interface, how we configured it. Okay, the interface is turned on. The IP address 191.168.20.1 is correct. Let's point our mouse over to PC 0. 191.168.20.2, 191.168.20.3. Point our mouse over to left router. 191.168.20.1. Okay, that all looks good. Okay. Let's check our port numbers again. So on this switch, we didn't do anything with the switch. What I'll do is I'll just try to reconnect the cable, okay? I'm going to click on this delete button right here, which is the X with the arrow pointing to the left of us. Click on it. And it's going to ask us, do you want to delete switch 0? We can go ahead and delete it, and we can just try our connections again. I'm going to hit the escape key. I'm going to drag a switch up here. And from here, I'm moving things around. I'm going to click on the Thunderbolt, select copper straight through, click on Fast Ethernet 1, and connect to gigabit 000. Okay, and then I'm going to click copper straight through cable, connect on PC 0, select Fast Ethernet 0, click on the switch. I'm connecting to any switch port, and then we'll make our third connection. Again, copper straight through, connect on port 3. Now, if you want to fast forward time, you see where it says time, and you got the double arrow pointing to the right, just click on it. Okay, now all the arrows turn green. So it was just something with the connection. I don't know. How do I use the wrong cable or connected to the wrong port. Anyway, we fixed it. We deleted the switch. We just dragged a new switch up into the workspace. Used copper straight through cable to make our connections. And then from here, let's make sure that the PC 0 can ping the gateway. Again, it's part of troubleshooting. So we click on PC 0, go to the command prompt, type ping 191.168.20.1, which is our gateway, and we get a reply. Okay, I don't think we need to do it from PC 1. I think everything is up now. Okay, and then from here, now that this network is up and running, the left router should be able to advertise the network on an autonomous system to the center router. So we can go back to the center router and hit the up arrow and look at our routing table again and hit enter. Okay, and then you see the second BGP route that popped up. Okay, now the weird thing is I don't know what caused it, right? But we troubleshooted it and we fixed it. Could have been a packet tracer thing. I'm not sure. I might have originally used a crossover cable by mistake and then used the correct cable, somehow threw everything off. I'm not sure. But simply by, in the real world, you would just, you would kind of treat this maybe as a bad cable after verifying the addresses are all correct and all the configuration is correct. Then the only issue could be a cable connection. It could be a bad cable, it could be the wrong type of cable, or maybe it isn't pushed through all the way, right? So you know how you have to hear that click when you push the RJ45 jack into the slot? Could have been that as well, okay? Anyway, we got it up and running, right? The center router is able to see both networks, okay? And so we can go on the left router and again run through these BGP show commands quick and hit the letter Q. We're on the left router now, and we type show IP BGP neighbor. Again, we got one neighbor this time, which is 1.1.1.1, which is the center router's address, and the remote autonomous system for it is 35, and the center router has a BGP router ID of 5.5.5. So actually it has the highest IP address as far as the router ID is concerned. Okay, you can hit Q for quit, and then you could type the command show. I'll abbreviate the command IP BGP summary. Notice everything's abbreviated. Okay. And so here's the command here. Here's the output. Okay. This identifies us, right? Our router ID on the router on the left is 3.3.3.3, and our local autonomous system number is 20. Okay. And our neighbor is 1.1.1.1, and its autonomous system number is 35. Okay. You can minimize that. And then you can go to the router on the right. Okay, type enable and type show IP BGP neighbor. And I'm abbreviating that. Okay, and hit enter. Again, its BGP neighbor is 2.2.2.1, which is the center router. The center router's remote autonomous system is 35, and the router ID on the center router is 5.5.5.5. So I hit Q and type the command show IP BGP summary. Okay. And you can see from the output, this identifies you, right? The router on the right, your router ID is 4.4.4.4. Your local autonomous system number is 50, okay? And you can see who your neighbor is as well. It's the center router 2.2.2.2.1, and its autonomous system number is 35. Now again, you want to look at the routing table, show IP route. You want to be able to see the route from autonomous system number 20, okay, being advertised to you. So you hit enter, and as you can see, you have a route being advertised to you. Now look who it's coming from, right? It's not being advertised. It's coming from the center router. So, right, in BGP, the left router advertises its network to the center router, and the center router takes that network and advertises it to the right router. And the right router is learning it from this interface right here on the center router. Okay, so the right can see the autonomous system number from the left router. And so the only thing we need to do is we've already saved the configurations on the router. If you want to do a copy, run, start again, that's fine. Hit enter. This time you can close the window. We won't be needing it anymore. And you can go to center router. If you want to do a copy, run, start again, hit enter, close the window. And the last thing we need to do on the left, right, is look at our routing table, show IP route, to make sure that we can see the autonomous system number 50, right, that's advertised by the router on the right, that's sent to the center router, and then the center router takes this network right here and advertises it to us. And right, how do we know that? Because you could see under BGP who we learned the route from. We learned it from 1.1.1.1, which is the router in the center, okay? So we can do a copy, run, start. Okay, and hit enter. You can close the window. Now that you have what's called full convergence, and what that means in English is each router can see everything that they're supposed to see, right? PC0 should be able to ping PC4. We know that. And for whatever reason, if it can't ping the PC4, then it's either we assign the wrong IP address to PC0 or the connection is bad somewhere along the way, right? Because the layer 3 routing is fine, right? We got full convergence. We looked at the routing tables and did our BGP show commands, right? So what you have to do is work your way down the OSI layer. Say, well, if layer 3 is correct, we have to look down to layer 2, the data link layer. We got nothing special going on the switch. We have no VLANs. We're just using the default VLAN 1, so that's okay. So then you got to go down to the physical layer and check your connections, okay? So with that said, we will ping the PC4 from PC0, and the PC4 has an address of 193.168.20.3. So we'll go to PC0, click on the command prompt, and we'll type ping 193.168.20.3, or 2, which is the address, or 3 is the address of PC4, that's connected to the right router. And hit enter. And we may have to give it time for it to come up. It should pop up here momentarily, and there it goes. Okay? And then you can hit the up arrow if you want to get 100%. You can do that. And then you need to ping the PC, ping the other PC on the .2 address, excuse me, which is PC3, and give it a second. Now, why is it timing out the first time? Right? It's because of address resolution protocol. An ARP query needs to be made because PC3 did not have that gateway address in its ARP cache, something that we talked about in an earlier lab. So I had to learn that. So what Packet Tracer is doing is simulating that delay. But once you have the gateway in your ARP cache, right, then it pops up to 100%. Okay? So you have everything saved and everything's complete. The last step is to go to, again, you go File, Save As, give it a file name, and upload it in the assignment area, and you're good to go. Okay? So this completes the lab, and take care.